We are going to finish our exponential function unit. So let's look at slide 23. It says domain and range from a graph. I'm going to zoom in on the left side. So let's think back at when we learned about domain and range. Domain is all possible x values, and range is all possible y values. So if we look at this one, we have this graph. The domain is our x, so the arrow on the right side means it goes on and on forever. We talked about the asymptote, right? An asymptote is like on this one. This one was the x-axis because it gets closer and closer to the x-axis without ever touching or crossing. So that affects your domain and range. For this one, the domain was all real numbers because your x values go from left to right to infinity. But our range is the one that's affected by that asymptote. It is at 0 or greater. So y is greater than 0. So this is looking back at slide 20. So slide 23, we need to create a little text box here so we can put our domain in there. For this one, because it has arrows, it's going on and on to infinity. So our domain is all real numbers. We can also write it as an inequality. So sometimes you're asked for a word description, which would be all real numbers. Other times you're asked for the inequality. So for all real numbers, that's represented by x is between negative infinity and positive infinity. So we'll put negative infinity. Do you remember how to find infinity? Yep, insert special character. We're going to draw a little infinity sign there, and it should pop up. And that was under insert. Insert. So negative infinity is less than x is less than infinity. I'm going to make this a little bit bigger. Extend it out. There we go. So those are two ways to represent your domain. Now our range is our y values. So it would be closer and closer and closer to 0 without actually touching. So let's draw our asymptote. So get the line tool, and it is on the x-axis. So draw your asymptote on the x-axis. I'm going to color mine blue, make it a little bit thicker, but then make it dotted or dashed. I don't like it like that. I want the dashed. Maybe I want a different color. Something that we can actually kind of see. There we go. So it's going to get closer and closer. I think about it as it's skating along the edge without ever going over the edge or touching the edge. So then our range is affected by that. It's going to be above 0. So y has to be greater than 0. It's not equal to because it doesn't actually touch it. So y is greater than 0. I'm going to copy this over to the other part of the slide so that I can just adjust it as I need. I know it's not the exact same, but I'm just going to use that as my template. So let's look at the domain. Domain is your x's. So this arrow tells me it's going to continue to get bigger and bigger and bigger. It's going to go to the left forever and to the right forever. So the domain is all real numbers, negative infinity to positive infinity. And then our range, let's draw the asymptote. I'm going to copy this one, Control C, Control V. so that I have an asymptote that I can work with.
Yes.
So that's also along the x-axis because it's going to skate along the edge without it ever crossing it. But what's different about this one versus the other one? Where is the graph? Where is that function? Above or below it?
Below.
So that's going to change our range. So what are the values of y? It's not going to be greater than. Since it's below, it's going to be less than 0. So y is less than 0 for our range. Let's move on to slide 24. On Friday, we talked about exponential growth and decay. So let's move on over to domain and range on the right-hand side. If you were not here on Friday, this was a slide that we copied over. I think this one was also. So you have to go to Google Classroom, to Friday's topic, copy and paste the slide over. That was talked about in Friday's video. All right, domain and range of this one. What is different about this one versus the other one that we did? All the other ones that we've done so far. What do you see at the end of the function?
Oh, closed circle and open circle.
Yep, open and closed circles. So it's not going on to infinity, it stops. It's called being restricted to a certain spot. So our domain is our x's. So let's look at our x-axis. How far left does the function go?
Oh, -2.
-2. I'm going to put a little circle there. It goes to -2. And I'm going to make it transparent. And, well, I'm going to do a color. I'll do it pink. But then I'll make it transparent. So I think I got to do custom. Custom color so it is transparent. I'm going to zoom in a little bit more. There we go. So it goes to -2. So once you make this little oval here, you can copy and paste it so we can use it on the other side. So on the x-axis, it goes to -2 because this is all the way to -2. And then the right side is +2. So our domain goes from -2 to +2. So x is between -2 and +2. But the thing that's different here is our open and closed circle. When we do open circle, it's not actually included. Closed circle, it is actually included. So whenever we do our domain, x is going to be between, so I'm going to put -2, put a couple spaces, x, +2. Then I need to go in and fill in my inequality symbols. So for -2, it's actually included because that closed circle. So it's less than or equal to. You can find a special character or you can do the less than symbol and then underline it. And then for +2, it's an open circle, so it's not actually included. So we put less than. Okay, so what might be confusing is why we use less than symbols. And the reason we do that is because we're writing our numbers in order from least to greatest. So this is saying x is the least amount -2, the most amount 2. So from -2 to +2. Okay, our range is next. So range is how low and how high it will go. So I'm going to use these circles again, copy and paste, but I'm going to change the color. I'm going to do it more as an oval going this way. think I want to do like an orange color, but I want to make it transparent. Okay, so the lowest it goes for the y value is -5. And then the highest it goes is 10. So it goes down to -5 and up to 10. So since we're dealing with range, we know that's the y values because we're looking at the y-axis. So the y values are between, what's the lowest? -5. What's the highest? 10. So I just write -5, y, and 10, and now I fill in my inequality signs. Which inequality sign do I use for -5 since this is an open circle? Is it included? No, because it's open, so it's not actually included, so we just use a less than sign. And then the range for the 10 is included because that closed circle. So we would say is less than or equal to. I'm going to copy this less than or equal to put down here. Makes it a little easier. There we go. So we have our domain and range written as inequalities. All right, let's move on. Okay, we have these two, an exponential function containing these points. We have those points, and we have domain, we have range. So how could we do our domain and range? So our domain is all possible x values. So what are the x values that we're given for those points? Okay, so the domain, we probably just need to graph this. So get out your composition book and let's graph it. Going to write on here, domain and range of exponential functions. And this is slide 24. Let's draw an x and y axis. So it says an exponential function containing these points, -1, 0.2, 0, 1, 1, 5, and 2, 25. We just need 3 points on this. So let's just go by ones. So it says 0, 1 would be right here. And then it says 1 of 5. So 1, 2, 3, 4, 5. And negative 1.2. So negative 1 and 0.2. So if we were to make this look like an exponential function by connecting our points, it would look like this, right? And it'd get closer and closer to the y-axis without ever touching.
Wait, so on that one, we go 1 to the left and then 2 up?
0.2. On this one,
Yeah.
0.2. So half, so that'd be 0.5. So then you'd have less than half. So this would be 0.5. So I would go to 0.2, which would be a little less than half of that. So then the domain is our x values. It continues on and on and on. So what is our domain? All real numbers. Do y'all remember what the symbol is for that? Is that R with that extra thing? And we can also write negative infinity is less than x is less than infinity. Okay, and now our range, which is our y value. So what is our range on this one? Say that again. Yep. Y has to be greater than 0. Because your asymptote is along the x-axis, which is at 0. That's your asymptote. It's never going to cross it, so that's what makes the y be greater than 0. Okay, so let's go back to our slides so we can fill that in. So all real numbers, or the negative infinity, positive infinity. And then our range is y is greater than 0. And the next one, an exponential growth function with the asymptote at y equals 0. This is going to look just like that last one, or something similar. The growth rate might be different, but it's still going to have an asymptote at y equals 0, and then it's going to be growth. So it's going to go on and on forever. So it's actually going to have the exact same domain and range, because this one also has an asymptote of 0, and it's an exponential growth function. I'm just going to copy and paste this over. What if it was an exponential decay function? What would it look like? Look back over here. Exponential decay. It also has an asymptote at y equals 0. So it'd be at y is greater than 0. If you have an exponential decay function that also has an asymptote at y equals 0. You should be done with your slides now. If you don't have things in there, then you need to make sure to take pictures and upload those pictures into your into your digital interactive notebook so you can turn it in tomorrow. Your assignment, I'm going to pass out, is 8 problems about exponential growth, decay, domain, and range. You can draw a picture on this one just like we did our last one. And then this one you can graph in the calculator to look at that. This one is discrete. Discrete means you just have individual points that are not connected. So you're just going to list the points. List points, and it's not an inequality. So you'll do your x and y, and then your domain would be a list of your x values, and range would be a list of your y values.